Hi, my name is Fernanderos. This is my presentation on object detection and the limitations of YOLO. Why I chose deep learning. I wanted to explore deep learning algorithm because it is becoming more prominent in everyday lives, so I wanted to see what the people of this industry produced. Deep learning algorithm, what is it? Deep learning algorithm is what a machine uses to learn functions and skills. They learn through the input of data in a neural network. Neural network is hardware or software used to process data. Here's an example of neural network. It's forward propagation and backward propagation. Okay, so say you're teaching a machine to learn math. You input 1 plus 2. It goes to the hidden layer, which is the circle, and it will calculate the problem. Then it goes to the output, and the answer it will give is 5. So then you tell it that the answer was supposed to be 3. And you tell it that it was 2 away from the answer. So what it does is it goes back to the hidden layer, calculates and adjusts inside the hidden layer, and it keeps doing that until it gets 3, which is the correct answer. How is it used in the industry? Deep learning algorithm is used in security cameras, in the automotive industry, in construction sites, in the medical field, and in nuclear plants. How a neural network is used to process images. CNN, or convolutional neural network. Convolutional is a mathematical operation used in the hidden layers. Example, A times B equals C. It is used by inputting an image into the algorithm. The way the image is input is by each pixel it has. So if its size is 4 by 4 pixels, then they multiply the pixels. So it will be 16. There will be 16 neurons, and each neuron will be counted starting at 0 all the way to 16. So like 0, 1, 0, 2, 0, 16, stuff like that. Then it cuts the image into a grid and looks at each piece of the image that outputs the image. Algorithm issues before YOLO was created. Before YOLO, one object detection method used was called sliding windows. The way sliding windows worked is they used a grid to cover the picture, then they used a bounding box to slide each part of the grid until it detects the object. The problem was, sliding windows was not fast, and the grids could have been too big or too small. Here's an example of sliding windows. As you see, it goes from left to right, and it's pretty slow. It keeps going until it finds the object. Okay, so YOLO algorithm. What is it? A YOLO algorithm, aka you only look once, is an algorithm that was not only accurate but fast as well. With YOLO, it predicts where the object is in one look. It does not cut the image in pieces like sliding windows. It shows the whole image at once. This helps it in the real world, as it knows the environment the object would usually be in. When YOLO is being trained, it uses a bounding box to find what YOLO thinks is the right object, so it just scatters all over the place. The non-max suppression, a different algorithm, comes in and checks which bounding box is correct or incorrect, and removes the wrong ones. YOLO uses the anchor box. The anchor box is a bounding box that has the height and width and other data in the object it trained for in it. So the anchor box uses the data it has and finds the objects that match the data. Here's an example of YOLO. You see how fast it is? This automatically goes to the object. It doesn't go left to right or nothing like sliding windows, so it's pretty quick. Difference between YOLO and sliding windows. YOLO is much quicker than sliding windows. YOLO looks at the image once and predicts where the object is at, compared to sliding windows, which slides from left to right to find the object. Why is YOLO important? The YOLO algorithm is important as it is the best object detection algorithm we have, so it is used in many industries that use deep learning and object detection. Limitations of YOLO. Limitations of YOLO is based on closeness of the object in the picture, so if the object appears in clusters, they cannot find the small objects. If the dimensions of the objects are different from the images used in training data, then it will find it difficult in localization and detection of objects in the real world. Examples of the limitations. First pic shows the example of it if the box is not the right size for an object. So you see here, the red car, the anchor box fits perfectly right here. But you see these two cars right here, these black cars. The anchor box does not fit perfectly as they are too big compared to the red box. The second pic shows an example of if YOLO was trying to find empty chairs, and it's having a problem finding them since there's so many groups of people in it. So sees it like it can like see where it's at, but it can't like get it perfectly. It just gets the whole groups. Due to these limitations, people decided to improve upon YOLO by making a different version of YOLO. Versions of YOLO. There are many versions of YOLO. Here are a few. One is YOLO V2. It improved on accuracy, but the problem with YOLO V2 is it has a slow running time. YOLO V3 can better detect small to big objects, and its performance is improved over small sized objects. But that's pretty much all it could do. In YOLO V3, tiny, running speed is increased, accuracy is reduced though, but it still ensures good accuracy of the results. Limitations of anchor box. Limitations. Anchor box is set as a predefined rectangle. Scale and ratio are manually designed, and the anchor boxes can be too big. It never pays attention to the surroundings, which can lead to ambiguous label. Example, a dog in front of a couch. One anchor box can detect dog and labels a dog, while another anchor box detects the dog and the couch but labels a couch. So here's an example that I just explained earlier. As you see in the picture, the two anchor boxes overlapping, and even the one that detects the dog still reads the couch as well. So it is just not good. One solution for anchor box is the CBAF method. The CBAF method, or coordinate-based anchor-free module, is for object detection, and how it worked was it divided the image in several parts based on spatial coordinates. What CBAF does is collects the parts of the image as batch, then inputs them in CNN as batch, collects the batch and puts it in the classification and regression layer. They also encode the object in an anchor-free way. So here's an example. As you see, the dog on the couch from the last image, and you can see from later on, it gets separated and put into different batches. So now the dog is cut out, and the couch is just right there. It's just a couch without the dog. It'll be easier to label like that. Here are some proposed solutions. I was wondering if I could implement CBAF with YOLO, see the ways to make them work together, or if I could de-anchor the anchor box in the YOLO algorithm, since CBAF has already de-anchored their anchor box and it seems to work well for them. In conclusion, and future work. In conclusion, the YOLO algorithm is a major part of the deep learning industry and is used by many. If we aim towards perfecting YOLO, we can feel confident in the machines we use it in. For future work, I think I need to do more research on the CBAF method and more research on the different types of YOLOs that they had. And that's it. Alright, well, goodbye.